Okay, so now that we know the phase change diagram, now we can calculate how much energy it takes to go from one part of the diagram to another. So this is phase change example problem 1. So how much energy does it take to change 29 grams of ice that's going to be at negative 15 degrees Celsius to steam at 155 degrees Celsius? So if we remember the phase change diagram, okay, this is your time and this is your temperature. We have this 5-part curve, okay? So this is where it's going to be ice. This is the flat part where it melts. This is where it's going to be water. This is where it is going to boil. And this is where it is going to be steam. And then for reference, we know that water is going to melt at 0 degrees Celsius and it is going to boil at 100 degrees Celsius. So if we start looking at all of this, we are starting at ice at negative 15 degrees Celsius. So about here. And we are ending with steam at 155 degrees Celsius. So about here. So to get from here to here, I have quite a ways to go. First, I'm going to have to melt the ice. Then I'm going to, or heat up the ice. Then I'm going to have to melt the ice. Then I'm going to have to heat up the water. Then I'm going to have to boil the water. And then lastly, I am going to have to heat up the steam, like so. So you see that there are 5 parts of this curve to do. So this first part here where the ice is, there is a slope here. So I'm going to use Q equals mc of ice delta T in order to figure that out. Then in the second part where it's a flat plateau, I'm going to use the delta H of fusion in order to melt that ice. The third part, I'm going to use Q equals mc of water, let's write water, delta T, and then I'm going to boil it with m delta H of vaporization. And then our last part here is going to be our mc of steam, delta T. Okay, so once I get all of those 5 individual parts, I can add them up and get my total amount of energy in my reaction. So that's exactly what I laid out here for you. If you can't read my writing, we change from ice from negative 15 up to 0 degrees Celsius. You melt the ice to water. Oops, that went back. Then you heat the water from 0 to 100 degrees Celsius. You boil the water to steam, and then you heat your steam from 100 to 155 degrees Celsius. All right, so again, we are starting here at negative 15 degrees Celsius, and we are ending up here. Whoops, why aren't you writing all for me here? At 155 degrees Celsius, and we have to get through all 5 of those parts right there. Okay, so we use our delta mc delta t equations for any time there is a slope. So there is a slope here, a slope here, and a slope here. And any place where there is not a slope, where there is a plateau, we use our delta H of reaction equation. Okay, so it really does help if you map it out on your drawing. Okay, so plug everything in. It's always going to be 29 grams. 29 grams of ice, 29 grams of water, 29 grams of steam. You have your different constants, 2.03. Okay, you are going from negative 15 degrees Celsius to 0 degrees Celsius. So since delta T is TF minus TI, you are going to see that we are 0 minus negative 15, or get a positive 15 degrees Celsius. That is possibly the second most common mistake that I see here. Okay, 29 times 333.3 joules per gram. I mean, joules or grams, so then my grams will cancel out, leaving joules. You use 100 degrees, the full range of water for your delta T there. And your M delta H of vaporization is going to use that constant. Your grams and grams will cancel out. And then possibly the biggest, most common mistake that I see is people don't use the right delta T here. Okay, so at the top part of the graph, okay, you are only dealing with this tiny portion. Remember, this is where you boil. So this is 100 degrees Celsius. So if you are going to 155, you only want the temperature range right there. So TF minus TI gives me 155 minus 100, and that is just 55 degrees. So this is the most common mistake that I see. Okay, so don't make it 155, make sure it is 55. Don't make it negative 15, make sure it is 15. All of those should be positive together. Once you get all 5 of these numbers, add all 5 parts up, and then you get 91,338 joules. If it is over 1,000, convert to kilojoules by moving the decimal place 3 times. 91.3, that's what we do in polite circles. So that is how you do a 5-step phase change example calculation.